Then welcome everybody again from my side. We're excited to have so many of you here today in our workshop. My name is Sven. I'm today's moderator, and in that role, it's my job to do some housekeeping first because before we start in. Um, First thing, we're aiming for an interactive format here, despite the virtual. So if you have any questions, doubts, own experiences, please post them in the chat. During the talk, we can use that to have a discussion. And I've also brought Jonas here with me, who will be helping out answering questions directly in the chat. And I will also forward them to our speakers so we can have a discussion on audio. Plus, we'll have breaks in between and some spare time for discussions at several points, so we can have a lot of exchange here in today's event. Also, if you feel better asking your questions in German, please feel free to do so as well. We can translate that if that's more comfortable. Final thing, if you let's put it another way around. We would appreciate if we get some feedback from you about the event content-wise and also the format we have here, so we can improve ourselves also with our workshops. And we'll have a poll for that in the end of the Zoom session. And also when you leave the Zoom session, there will be a survey opening up in your browser where you can give us some free text feedback, and we'll really appreciate that. To improve our event format further as we go along. That's it for the organizational side. Since I've seen there's some new faces here in the room, I quickly want to introduce ourselves. We are CQSE, a company dedicated to the topic of software quality in January, it's going to be 17 years. Now, we have our headquarters in Munich, Germany, but we're spread all over Germany and into the US these days. We're developing the tool TeamScale, and which is a system for improving all kinds of quality aspects. And one of those aspects we're going to talk about today, which is test gap analysis, where the idea is to identify untested changes so we can find bugs faster at the end of the day. And that this is a very relevant topic that you are proving, and everybody else who registered for the event. I brought here just an overview of all the companies who are represented here in the event today. And I'm really looking forward to get the input here from our speakers, which is Stefan and Johannes from our test intelligence team, two of our very experienced people actually working with test gap analysis with our customers in their day-to-day work. And I'm looking forward to have you two tell us more about the analysis and what we can do with it and what it can do for all the participants in today's event. So with no further ado, Stefan, please take it away.
Thank you, Sven. Let me steal the screen share. All right. Yeah, thank you. Before we dive into test gap analysis, just a few words about myself. I'm Stefan. I've been with CQSE for quite some time now, several years, and I'm part of the test intelligence team. Test intelligence team meaning we take into focus all kinds of different analysis, considering tests, including test gap analysis, but we also have a bunch of other stuff that we do. And on top of that, we help people on board using TeamScale and the test analyses. But we also support during their day-to-day business. And the result of those last few years of accompanying customers was usually that the software systems that our customers work on, they grow over time, and they grow and grow. New features are being added all of the time. But unfortunately, the resources for testing do not grow in the same manner. So usually we need to make sure that we are testing the right stuff at the right time. And this is difficult, and we need to figure out how to do this. And there's actually some research about this, and one of the key points from this research about how can we predict where the problems are going to be is we need to focus on changes in our code. And like in a nutshell, this is what test gap analysis is all about. We are going to focus on changes in our code and make sure that those changes have been tested as good as possible. And the first question might be, how can we actually get those changes? And at first, when we started developing our product, we started by writing all features and bug requests, bug reports on a whiteboard. But as you can imagine, this doesn't really scale. So we switched to software products. First of all, we tried out Bugzilla, and then later on switched to Jira, like most of our customers are doing. And this was great. I mean, this was made things way easier to keep track of all the changes, of all the stuff that's happening. But what this also allows is it can give us some nice statistics about our tickets. And one statistic is the types of the different tickets, our different issues. And this is what I brought with me today. We had back in the day when this image was made, we had roughly 2,000 tickets in our bug tracker or issue tracker overall. And as you can see, most of those tickets are feature tickets. And this usually means that we have some rough understanding of what we should be testing, where the changes might be. Because if the ticket is well written, then there's some sort of explanation, what's actually going on, what's the feature supposed to do, what are acceptance criteria, and so on. So at least there's hope that this is like easily testable. The same goes for bug fixes. Usually, whenever you have a well-written bug report, focus on well-written, then there's going to be some steps to reduce this problem. So you also know what you should be testing. But there are also some types of tickets that even when the ticket is well written, it's rather difficult to find out what exactly has been changed while working on this ticket. And one area would be the maintenance tickets. For example, some refactorings that are being done, some works on the code that improve software quality. It's usually quite hard to, when not looking at the code directly, understand what has been changed for this. Another area would be dependency updates, meaning that some sort of third-party library, that there was an update and we need to adjust our own code to reflect this new software version of the third-party library. And actually, not the third-party stuff is relevant for us, but the changes in our own system that we need to make to make use of the new version. And also for those types of tickets, it's insanely hard to understand what we need to test later on. So this is the one area, depending on the type of ticket, it might be hard to get a feeling of all the changes. But there can be other examples where it's totally unclear what has actually been changed in our product. And one maybe extreme example, but it is an example that happened, is at one of our customers some time back. They had crunch time. This meant that they established a priority system of the tickets, and only the tickets with the top priority are being worked on back in the day. But they also had a sales team, and the sales team already promised a feature to a customer, and then noticed that this promised feature didn't make it to the roadmap. So it was clear that this feature, this promised feature, could not be shipped in the next release. But the salespeople remembered that they knew someone from development, and they just asked the developers, hey, can you add this feature under the radar? Don't mention it anywhere. Just we know about this because we want to sell this feature. We need to ship this. So you can imagine that the testers had no chance at all to even see this new feature because it was all developed completely outside of any issue tracker. And this, as I said, might be an extreme example, but even if you don't do this flying under the radar, and if you do have a proper testing system, still it's insanely easy to have some of those changes slip through production untested. And one of our earliest customers, the Munich Re, they actually asked themselves the same questions. How many of our changes that we do, even though we have a pretty rigorous testing system, testing workflow, how many of those changes go into production without ever being tested? So they and we together, we did a study, and we took 2 releases and had a look at how much of the code has been changed and how much has been tested afterwards. And for the first release, roughly 50% of the code has been changed or added during this release time. And over 50% of all of those changes made it into production completely untested. This was pretty shocking to us, of course, also, but even for the Munich Re people, because their testing process was so good. So we had to look at another release, and we saw similar numbers, maybe even worse. Again, roughly 50% of the code has been changed in this release, and then even over 60% of those changes made it into production completely untested. And this was a crazy number. Yeah, because nobody expected it, because the testing was actually pretty good. And this was the first part of the study. And the second part was, okay, now we know that many changes make it into production untested. Is this actually bad? Can we see how much more bugs do we have in these untested areas? And so the second half of the study compared the tested areas and the untested areas of the code and had a look at how many bugs occurred in those areas later on in production. And the result was that the probability of production bugs was 5 times higher in those untested areas compared to the tested ones. And this was a nice result for the study because there's something to show. But the people from Munich Re, of course, they wanted to have this information not after the release, but before the release. And this basically gave birth to test gap analysis because we wanted to have some sort of tool that could show you before it's too late, could show you where are changes in your system that have never been executed during testing. And this was the motivation for test gap analysis. And on a very high level conceptual base, the idea is that we take changes from your software system, then we take coverage, we take execution data, and then we overlay the two. And test gap analysis gives us all of the changes that are being untested. That's the concept, but we also need to make sure that people can actually use the results. So we tried and figured out a proper visualization for those data points. And we use tree maps for this. And this is exactly what a tree map looks like. We have a bunch of boxes. Basically, the bigger the box, the bigger the thing that's inside it. In this case, we have components of our software system. So the bigger the box, the bigger the component. And then we can zoom in. Now we're going to add files to our tree map. And again, the bigger the box, the bigger the file. And now we zoom in even further. And now every box is one method in the software system. But the same holds for the size. The bigger the box, the bigger the method. And what you can see right now is a whole software system in one image and all of the different methods in the software system. And the method level is also going to be like the zoom level that we are working on while talking about test gap analysis. So we have the code. Now we need changes. And we visualize those changes by using color. Everything that is gray means it has not been changed in the time frame that we have a look at. could be, I don't know, from your last release to the current date. And everything that has color in this picture means that there has been a change. A red box, a red method means this method has been newly added. And an orange box means that this method has been there before, but it has been changed. So we have our changes. Now we need our coverage data, our execution data. And this could look like this. What we did is we just collected coverage from all different kinds of sources. Could be automated tests, could also be manual tests. This is pretty important. So you can also use manual tests as a source for test gap analysis. And now the only thing that's left for us to be doing is overlay both pictures. And this is what it looks like. We can see that there's this big gray area in the middle again, or on the left side rather. This means that the gray area, this has not been changed. And I'm going to stress this a couple of times in this talk. Test gap analysis is all about the changes. So when something didn't change, we ignore it. But there's other colors. There's green, and green means the same as before. It has been executed while testing. So there has been a change, and this change has been executed. And then there's red, red meaning the method is new, but has never been executed after it has been added to the system. And orange is also the same as before. The method was changed, but after the last change, the method has not been executed. So we know whenever there is some bug hiding in this red and orange area, then nobody could have found this bug because it was never executed.
Maybe Stefan, just because the question came up in the chat here, and I think it fits well as at this point. Let's make it explicit. What kind of tests are we talking about here? Are these unit tests, performance tests, UI tests, manual tests, something else entirely? Let's clarify that.
Yeah, thank you for the question. That's a good one that we get like every time, I'd say. In short, yes, all of them. We're going to have a closer look at this later on. What we can do with TeamScale is we can collect all kinds of different types of coverage. Yeah, could be unit tests, could be manual tests, could be integration tests, component tests, and so on. And you can all aggregate them into one image. But you could also look at them separately. It really depends on what you wanna see. Usually, I'd say the default is just have a look at the aggregation, have a look at the whole test pyramid. What can your test pyramid change of your test of your changes?
Thanks for the answer, and thanks for the question.
Thank you.
All right, you're welcome. Okay, now that we have those test gaps, we need to make a decision what to do about them. And what should happen is that we meaning developers, testers, test managers, so all of the people that have stakes in reducing test gaps, we need to make sure that we improve our test suite. Improving means we need to add more test cases, we need to extend existing ones. And then with this new and improved test suite, we execute the test suite, get new coverage data, and then feed this new coverage data back into test gap analysis. And then we iterate. Basically, we iterate as long as we still have some critical test gaps left. And critical test gaps actually being a good segue to the next statement that we usually don't advertise to aim for 100% change coverage. It really makes a difference where in your software system this test gap is located. There might be a component that is incredibly important. I don't know, let's say your component that handles security. It probably makes sense to test as much as possible in the security related area. But there might be another component, I don't know, that handles some minor aesthetic change in your system. It's still worth testing this, of course, but you might not want to invest that much time in there. So we as humans, we always need to prioritize those test gaps and figure out which of them we should actually address. And even if you had 100% change coverage, it still doesn't mean that you can prove that a program is bug-free. But this is not a problem of test gap analysis. So basically, all software testing has this issue. Um, in most of the cases, we cannot prove that a program is bug-free. We can only show that this specific kind of bug doesn't occur while executing our test suite.
Let me chime in here with a question from the chat. Whether we are also looking at, for example, database schema changes here when we're talking about changes. Maybe you can answer that one.
Mhm. That kind of depends whether it affects your software or not. Like if you put those, if you put the code in team scale, then we can also see this. If you put like the schema in team scale,
Yeah.
we could also have a look at this, but you don't have to.
Mhm. Okay. And to also put that one out in the open, which tool has been used to generate this visualization you just showed us?
So this comes directly from team scale. Um, the tool that we built and that uses test gap analysis as one of the analysis included. And about like how can we actually collect the data that we need for team scale to render this image. We're going to come to this really literally in the next slide.
Okay, sounds good. Then take it further. Thanks.
All right. Yeah, if there are no other questions, I'm gonna move over to our technical setup. Because what we need is on the one hand, we need team scale in the middle that does all the work for us, but we need to add some connectors to different systems. One of them being your version control system, because we need those changes, we need to change information. And yeah, basically we attach to your version control system, can be Git, can be SVN, yeah, all of the major ones. And then we can see all of the different changes that are happening as they are happening. And then on the other hand, we need the coverage information. And for this, we use profilers. I guess many of you have seen them when executing your unit tests. Usually, you can see coverage from your unit tests, but we can do more. We can also see the coverage for, yeah, as I said, manual tests, for example. And we support a whole bunch of different profilers. Yeah, could be for Java, could be for C#. Depending on your technology, different profilers are used. But the principle is always the same. The profiler listens to your program while being executed and generates a report for this. And this report indicating to team scale which line or which method has been executed. This is then sent to team scale. And team scale can use test gap analysis to identify the untested changes. So that's what's happening on the setup side of team scale. This is what we need to connect to. And what do we get by this? Since we can attach the profiler to different test stages of your systems, we can also collect the different sources individually. So you could have your component tests separately from your integration tests, and then you are really able to look at the results individually. But if you want to, you can also have a look at the aggregation. This is really up to you, depending on what you want to see. All of this is possible. All right. Before we get over to the practical examples, do you have any questions left about the basic concepts and the basic setup?
We have one more question. are we limited to a certain tech stacks or languages here with this kind of analysis, or does this transfer to like any kind of technology?
So yes and no. So we are limited, but we support a whole bunch of technologies. So there could be some exotic variation that would give us problems, but we support all of the major technologies, all of the major programming languages, and we also support this collection of coverage for all of the major programming languages. I don't know if you have a concrete example, um, but yeah, if whenever there's a profiler for your language, then yeah, we should be able to use this.
Mhm. So I put the link to our docs in the chat, where it has a list of all the programming languages. So in case you want to check, can go there. Okay, no further questions.
All right. Then, now that we know like the rough concepts and how we can set team scale up, I brought with me some practical examples that yeah, that might happen to you or at least happen to our customers in the past. One example would be a hotfix test. This means that there was some sort of bug in production, and we need to fix this bug as soon as possible. Time is of the essence, but still we need to make sure that while fixing this bug, we don't accidentally introduce another one. So we still like we should test as good as possible. And this shows a SAP system and the result of one of those hot fixes. And you can see that only a small fraction of the software system is actually changed. And then after the changes were being done, the testers tested the hotfix. And this is the image that we got afterwards. And you can see that like some of the changes, they were being executed while testing, but we can clearly see that there are still some untested changes left. And then afterwards, something happened that should happen all of the time. Testers and developers, they actually communicated to, and figured out what needs to be tested in order to also get rid of the last untested changes. And what came out of this was the developers, they found some edge cases that they noticed while working on this, but the testers didn't know about those edge cases, so they couldn't really test them. And after they talked to each other, they made sure that developers and testers had the same understanding of what needed to be done and tested. And after the test suite was adjusted and reran, this was the result, meaning that all of the changes are now being executed while actually testing the stuff. So this was a great result, and after this, the yeah, hotfix testing was finished. Another example would be a classical release test. So you have a time where development happens, then you have some time where testing happens, and then you release. And one scenario that I brought with me is the testing happened in a test factory where a bunch of testers tested over 2 weeks' time in a whole bunch of test sessions, and even on different versions of the system. So while testing went on, bug fixes were deployed in a test system. So over time, even different versions of the system were tested over those 2 weeks' time. And after those 2 weeks, this was the test gap analysis result that was presented to the release manager. And the release manager got pretty nervous because we see those huge red areas, meaning there are huge test gaps. So they went on and investigated what happened. And there was actually some sort of communication problem. So the test factory was told to only test existing features, doing effectively regression testing. But all of the new features that were added since the last release, they were supposed to be tested by an automated test suite. Unfortunately, this automated test suite was supposed to be done in a project, and the project didn't finish in time. So all of those tests didn't make it in the test suite for this release test. And explains why there's so much untested code. The release manager postponed the release for another 2 weeks to really make sure that they had the time to test all those test caps. And what happened is they started a explorative test, mainly because they only had 2 weeks time, so the time was just too little to create a whole automated test suite for this. But they assembled a whole group of different types of people, different stakeholders in the system, and made sure that they really tested the system thoroughly in those 2 weeks that they had time. They had hundreds of test sessions, and again, they tested even multiple versions of the systems, bugs being fixed while the test still ran. And the result of this looked like this. So this is what the picture looks like after the 2 weeks of explorative testing. We can still see 3 test gaps that were identified as critical. The top one was actually code that was meant for the next release. So it's not really part of this release. It's not accessible yet. So it was okay to leave this as a test gap. The second one, the one in the middle, that's actually old code that was supposed to be removed and shouldn't even be in there anymore. So this was removed later on, and so this is also a test gap that is okay to have at this point in time. The last one, the one at the bottom, this is actually one test gap that was an untested feature. This was some sort of CSV export, and this was just incredibly well hidden in some obscure menu item. So nobody ever thought about testing the CSV export. So all that they did is they had a short retest, and then everything was green, and they were ready to release. So this was after those 2 weeks and more tests, they really had a good conscience in releasing. But probably as many of us do, we don't have this strict development testing release process, but instead we release like after a specific amount of time. And we always need to make sure that the features that we added are tested all of the time, basically. And this is why we introduced issue test gaps, meaning that for every single issue, for every single ticket that you can have your own test gap tree map. And this is how it looks like in practice. You have all of the changes that are relevant for a specific ticket, for a specific issue, and you have them in a smaller tree map. And we do this by adding, actually, let me get my mouse cursor over there. We do this by adding the ticket ID in the commit message that we have in our Git, in our SVN, and so on. So that's basically the same idea that GitHub uses, GitLab uses, or Jira uses. And this also works for us. So now we know for every single ticket what code has been changed, and then we can show you the tree map. The results are basically the same as before, or the colors are the same. When some box is green, some method is green, it means that it has been executed. And whenever it has the more dangerous color, it means that it has been changed but is still untested. But what's cool now is that we can also see the information from the ticket system, and we can see which developer actually worked on this feature, on this bug fix. And we can talk to them whenever we are unsure what to do. When there's some hard to reach area of the code, we can really talk to the people that implemented this and have a look at this together. So it really enables communication between testers and developers. In order for this to work, we only need one additional thing. We need to attach to your issue tracker. And then we also need to have some sort of linkage between the changes, the commits, and the issue. So yeah, usually you would have this in your commit message. We can also read branch names, for example, and look for the IDs in the branch names. And that's it. As soon as we have this information, we can give you an issue test cap. All right, now we've seen a bunch of slides, and in a second we're gonna jump into a proper demo of TeamScale, showing you the like test gap analysis in action. Before we do this, do you have any more questions about the concepts, about all of the stuff that we've talked about so far?
Let me forward you two more questions that we have been discussing in the chat meanwhile.
Mm-hmm.
First question is, and I think you've just explained that in a way. How do we actually trace the code changes to impacted business requirements? Would that be through the tickets that you just showed?
Exactly. So if you mean like really a ticket by this, then exactly that's it. We have yeah, some textual link between the changes and the ticket that you're working on. Yeah.
Mhm. There's another question that goes into a similar direction, I think. For the issue test gap analysis, are you only using the automated tests, or if there's manual tests involved here, how do you link the manual tests to the issues?
That's a very good question. Yes, we use all different sources as I've shown you before. And I guess Johannes can show you this in action in a second. But just a few words about this. Technically, there's basically no difference between the automated test and the manual test, at least from the coverage side. For us, coverage is just a file, usually an XML file, and we don't really care whether this XML file is generated by using or by executing automated tests or manual tests. So all of the stuff that works for automated tests also works for the manual ones. And also, of course, this issue test gaps. All
Sounds
right.
good. Let's dive into this in the demo part. I have one more question here that I would like to forward uh, because it's really showing the variety of tests and systems out there. What about software that we can really run in an instrumented version because of real-time requirements on performance? So what do if we have really strict requirements on the performance of our system, and that might be um, yeah, tempered with by instrumentation of our code, of our binaries?
Yeah. Yeah. Very good question. So this is a problem. There's basically a bunch of solutions. First of all, maybe performance is not as important as you thought, basically, or the impact is not as big as you thought. This is what usually happens. So in the end, it's just not noticeable that you have instrumentation going on in the background. But there are cases where it is important and you do notice. And then what you can do is you have yeah, basically one version of the software that you run without instrumentation during your performance tests, and then an instrumented version that you use for actually extracting coverage.
Mhm. Makes sense. Something that Jonas also put forward in the chat is that especially for embedded systems, we sometimes have the option to also use a hardware profiler, which does not have any performance impact at all. So that might also be an approach if the
Yeah,
requirements are really strict.
yeah, absolutely right. Yeah.
Okay, sounds good. That's, I think, all the questions we currently have in the chat. Thanks for asking so many of them. Uh, it's really fun to have such a lively discussion going on.
Thank you.
And I'm looking forward to see more during the demo.
All right.
Yeah.
Then, Johannes, I'm gonna hand over to you.
All right. Thank you very much, Stefan. Just maybe a few words about me. I'm Johannes. I'm in the same team as Stefan, so also part of the test intelligence team. And yeah, we actually started working quite at the same time. So I'm also working for CQSE for several years now. And I'm very happy to dive with you into the demo and show you how you can use the test gap analysis with TeamScale. Before I go into TeamScale itself, I just want to quickly show you the application that I brought with me as well, which is the digital bank, because we need a system under test to actually show you how to use the test gap analysis in practice. The digital bank is a open source Java application, and yeah, it mimics standard banking software, so you can create accounts, you can do deposits, you can do withdrawals, or you can send money between accounts, all that kind of stuff. Yeah, and now without further ado, I want to jump into TeamScale. So maybe a quick word before, I will now jump into the role of a tester. And I was tasked with testing if a feature was implemented correctly. And this is what I will do with TeamScale. What you can see now here is the login mask of TeamScale. So this is a server application which can be hosted either by us in the cloud or on-premise. And yeah, now I will quickly log in. And now I'm greeted with the main interface of TeamScale. Before I talk about the tree map, I want to just say a few words how you can navigate through TeamScale. So you can see on the left here, there's this navigational sidebar where you can switch between the different perspectives. As Stefan already mentioned, there are several analyses coming with TeamScale. So most of these perspectives are corresponding to one of the analyses. For example, the findings and metrics perspective are relevant for the static code analysis and so on. Furthermore, there is this horizontal bar on top where you can also navigate a little bit through the different projects in TeamScale, for example, which would be the first entry here. So there can be multiple different projects inside one TeamScale instance, and here you can switch between them. We already pre-selected the digibank. Then for Git systems, you can also switch between the branch that you want to have a look at. And in our case, we're currently looking at the master branch. And lastly, since we are on the dashboard perspective, we can switch between the different dashboards that are existing. So in our case, our dashboard is just showing one single widget, and this one widget is a test gap tree map. Now, this tree map is interactive. So not only can you see the pretty picture, but you can also gain some additional information about the different methods and also where in the software these methods come from. So for example, if I hover over this, I can see the method name and the state. And if I click on it, I can also see the package names and the actual file. I could then also go and see the method history if I click here, which shows me all the different commits that actually changed this method, and also the coverage uploads if there were any. I could then even go one step further and see the source code of this method and the file if I click on this little link on top here, but I will not do this right now. Yeah, one more thing that you can also do when navigating through the tree map is you can use the drill down mode where you can quickly navigate through different packages, which is always a very simple way to find out different areas that might need some additional testing, because you have the names of the packages, which are usually very useful to know where the areas are that need additional testing. Now, as I said, I will jump into the role of a tester that was tasked with testing a specific ticket. In our case, a ticket is a issue coming from Jira. So I will go to test gaps and then issues. And now we can see an overview of the different tickets that TeamScale knows about. Already in place here is a filter that only the tickets are shown that are associated to my user. I could also say, for example, here, show me all the tickets that are relevant for a specific release, or I can define my own custom query where I can use a query very similar to how Jira does it and define it in a way that is relevant to me and save the query afterwards so that actually anyone who you share this query with can use it and you can use it at a later point in time. Jumping back to my issues, here we can see the different tickets, and in this case I will go to the ticket prevent deposit smaller than 0, which is the ticket I was tasked with testing. As you can see here, there's some information coming directly from the issue tracker, for example, the title and the ID, who worked on it, and also some meta information, and most importantly, also the description, which helps me to actually construct my test around. So in this case, I see that I should check if deposits smaller than 0 are still possible, because if they are, then the feature or the bug fix wasn't correctly implemented. What we can also see already is the test-gap tree map for only the changes that were done for this specific ticket. In our case, these were 4 methods that the developer touched. And we can already see that one of those methods was already tested, probably by some automated test that already ran after the developer committed and pushed its changes. And then further down, we can see the different commits that the developer did in order to implement the changes for this ticket. And here we can already see the linking that Stefan already explained, how we can map the changes to this one ticket by this prefix here with the ticket ID. Now, what I will do now is I will just construct my test the usual way that I'm used to. And for this, I will just start up my system under test. So now here I'm brought to the main interface of the digibank. I will log in. And what's happening in the background that I as a tester don't really notice is every line of code from the digibank that I'm now executing by clicking through the UI and doing a bunch of stuff will be written out and then later converted to a coverage report that is sent automatically to our TeamScale instance and then analyzed for our test gap analysis. So now I jumped into the deposit perspective. I select an account and I will just try to deposit a negative number. And we see it didn't work. So this looks like the ticket was worked on correctly. Developer did a good job. And I will now end my test. As I just explained, during this, the coverage was actually recorded and automatically sent to TeamScale. And as you can see, it was already analyzed quite fast. And the picture of the test gap tree map changed. We can now see 2 additional methods that are now seen as tested. And most importantly, we can still see one method, which is called withdraw, that is still untested. So this was changed specifically for this ticket, and we didn't test it with our test that we just constructed. And now, you could maybe ask the developer, is this important functionality that was changed here? Do I need to redo my test? In our case, I know that withdraw sounds important, so I will just redo my test, and then this time I will try to test the withdraw functionality. So I will start up my system under test again. I will sign in. This time I will go to withdraw, and I will just do the same. I will just try to withdraw negative money. Oh, and we can see this worked. So actually, we got rich by trying to withdraw money, which is nice. But in our case, this means that something is still not working as expected. So again, I will end the session here. I will go back. And this time you could see how the picture changed, I guess. But everything is green now, which again, we need to emphasize does not mean that everything is working as expected. It just means that everything was executed actually in a test. In our case, we know there's still a bug left. And this is what we tell the developer and tell him, hey, please, there's still a bug. Can you fix that? And he says, of course I can. I will quickly fix it, and which is what we do here. So in the background, all that is done is a commit is done, which contains the changes that are needed. And if I go now to the activity perspective, that is showing everything that is happening inside of the repository, basically all the changes that are happening. I can now go to the branch, prevent negative deposits, because this is the feature branch that the developer worked on. And now here on top, we can see the latest commit done by the developer. And if I click on this little link here, I get brought back to the ticket. And I can see the picture changed again, because of course, he needed to rework something in the withdraw method. And this is why something is still seen as untested now, because it was changed again after the latest test. Yeah, and that's basically already it. How we can, or how the test gap analysis can help you during your testing process to identify potential issues that are still hidden inside of your software. Are there any questions about this?
So there are currently no new questions in the chat, but if you have any questions at this point, you could also use your microphone, which are working, and feel free to ask any questions directly.
Yeah. Hey,
Hi.
sorry, I missed exactly how you tested it. It seemed like a manual test that you did, right?
Yes.
Okay. So you as a tester are confirming that you tested. Was there a point where you confirmed you tested it rather than, okay, you did a few clicks, you tested it, and it assumes you did? Or was there a point where you said, okay, I tested it?
I I went through the UI and I actually basically constructed my test around the description, and then I saw that there was one method that was still untested, and then I redid the test and I actually went to the UI and tried to deposit a negative amount. No, I tried to withdraw a negative amount of money, and then I saw that this still works, and this is how I determined that the test or my second test failed. So I had to give that information to the developer. And now what I did not do is I did not test again after the developer fixed the bug that I just discovered. I can also do that. So
Yeah. I'm sorry, just to clarify, was there
yeah.
a point where you declared as a tester that I tested this? How did the system know? How did your software know that
Ah,
you tested it?
okay. So now I understand the question. So no, as a tester, I didn't have to do anything manually. During the execution of my manual test, so clicking through the UI and testing this out, there's a coverage profiler installed that is writing out everything that is happening, and this is what TeamScale uses as a source of information to show you which areas were still untested or were not executed in a test. So manually, I didn't have to do anything because this is all done in the background automatically.
Okay.
But this data does not show whether the test was actually successful or not. This is what Johannes showed us in the end, that even though we found a bug, that the box was still green. So green does not mean that the test was successful. It only means that it was executed while testing.
Yeah, I realize that, but maybe a single test is not good enough. Maybe I want to really run 10 tests. Is there a human in the loop? Is there a tester in the loop that says, no, I'm not done yet, but I want to do 20 tests?
I mean, so in theory, there would nothing would stop you from doing 20 tests. The system would still recognize everything that is happening and recognize the different coverage sources from the different testers or the different tests that were done, and then aggregate them.
It seems to me that once you do one test, this will show as covered.
Yes, this is why we always say the focus is never on the green areas, because about the green areas we know the least. Because we can never prove that there are no bugs left inside of the things that we actually execute. We can only know that for the things that we never executed, then we cannot have found any bugs. So, and usually what we see at the customers or at our customers is that there are many parts left that were completely unexecuted or were never executed at all, that it makes sense to focus on those areas first.
No. And maybe to tie this back to the question, yes, definitely, there's humans in the loop here. So we're not making the role of testers or test managers obsolete in this with this. So we're still assuming that there's people who know what they're doing and who do thorough testing of the software systems, either by writing automated tests or by doing manual tests or whatever kind of tests you have. What we are aiming at here is to help you ensure that nothing slips through without you noticing, because we realize that in practice, this happens quite frequently, that things slip through without you noticing if you don't have a way to actually see that, to track that. And that's why we're helping here by pointing out these untested areas, because for the untested areas, we know for sure no test ever ran through that, so we cannot have found any bugs that are in these untested parts of the system. And that's why we're focusing so much on those on untested changes here. That's like the areas where you can most easily reduce the number of bugs, because I mean it's intuitive, and we could also confirm that with several of our customers that the most bugs are left in those parts of the system that you changed but that slipped through testing.
So I realize that it covers that minimum requirement. And still, I'm wondering if there's an override by the tester to say that, well, I'm still testing this. Don't turn it into green to show that it was tested. I'm still testing this. Is there a way to show this, that I'm still working on this?
What you could do is, for example, if you would say that the manual tests are not completed yet, then either you don't have to directly send the information to TeamScale yet, because you can just collect it and then send it afterwards. Or what you can also do is you can select a test stage where you say, okay, if I would not show what is happening on the manual tests, then I would see the picture from before. So then I can still say, yeah, there is something that might be important that might still need some testing.
Got it. Thank you. That covers it. Thank you.
Sure. Thank you for the question.
So are there any more questions meanwhile?
Just a quick question. Is this only for web application, or can this also be applied to mobile apps application?
This can also be applied to mobile applications. We did, especially for mobile applications, we did a proof of concept, even though we currently do not have a customer that uses it for mobile application, but we tested it in research and saw that it's working. But in general, it's not limited to only web applications, but all different kinds of applications.
Yeah, so we have customers from automotive, we have customers from insurances, we have customers from all kinds of different domains, even wind turbines. So there's all kinds of different systems and like technologies and hardware, from hardware to software systems where we can use that. So generally, that's very applicable to different kinds of software systems.
Okay.
Thank you.
Thank you.
This is actually a great transition to my last slide, which would be the languages that we support, because here you can also see the different technologies and systems that we are working with. Here are all the languages that we currently support in TeamScale. And also in orange, you can see those where we have customers that are actively using test gap analysis in these languages. And yeah, if there are no questions left, I would hand over back to Stefan.
All right. Let me share my screen again. There we go. All right. What's left for us to talk about is, we know that it makes, I hope that we know now that it makes sense to use test gap analysis from a perspective of developers and testers, but we can also have a look at this from the benefit side of view. Can we somehow quantify what does it bring us in terms of effort that we avoid? And we try to give an answer to this question by having another study with the people from Munich Re. That's the same slide that I've shown you before. And this is actually how we started the study. There was a change in management at Munich Re. There was a new CIO. And the old CIO, that was the one that introduced test gap analysis together with us. And the new CIO wanted to know whether all the effort and all the time that goes into collecting all the data needed, is it actually worth it? And in order to answer this question, we had a look at the data that was available. before the introduction of test gap analysis and after. And for this, I mean, as you might imagine, it's pretty hard to give you exact numbers for sometimes also stuff that doesn't really happen, for bugs that never made it into production because they were caught using those new types of analyses. So this is why we decided whenever we have a chance of selecting a number, we want to select the worst number for test gap analysis to stay as conservative as possible. And the first number that we have to choose on this slide is how big should our test gap be that we use for our calculation. And in this case, the 50% number, this is the worst number for test gap analysis. So this is where actually more has been tested. So it's less untested changes. So we're going to use the 50%. Actually, let me get some pointing here. So we're going to use the 50% from this slide, and we're also going to use this sentence over here. So the probability of production bugs is 5 times higher for completely untested changes. And what this sentence gives us is a metric that we call test ineffectiveness. And what we have is we have our untested changes. And for the untested changes, no bugs can be found because they were not tested. So 100% of the bugs slip through production. But still, 1/5 of the bugs also make it to production in the tested changes. So this 20%, this is another number that we need to remember for the next few slides. So this is the test ineffectiveness of even the tested changes. All right. Now let's dive in. Those are the numbers before we introduce test gap analysis. We can see all of the changes, and we have half of those changes completely untested. So this is our test gap. But that also means that the other half has been tested, but still because of this test ineffectiveness, some bugs still slip through production. Overall, that means that 60% of the bugs that hide in those changes are remaining. And now the question is, if we use test gap analysis, how can we improve those numbers? So we had to look at the same projects a couple of months later after the introduction of test gap analysis. And what we saw that depending on the project you look at, the biggest test gap, so again, the worst number that we could find is a 10% test gap. That means that 10% of the changes still were completely untested, but that also means that 90% of the changes are now tested. And if we add the test ineffectiveness again, this means that we have roughly 28% of all of the bugs that are in those changes, they still make it to production. But what we can see that we cut the production defects in half just by applying test gap analysis. And this was a pretty nice result. This convinced the new CIO to keep on investing in test gap analysis. They're still using this to the date. And on top of this, we also presented this at a conference some years back. So this actually, those results are published, and this is why I also can tell you about this in the first place. And yeah, this was really a great success story for test gap analysis. However, what I just showed you were like, yeah, conservative estimations. If you want to know more about this, in the end of January, we have a talk together with one of our customers, Vestas, and Vestas can actually put a price tag on bugs, and they apply test gap analysis, so they can actually tell you what they saved just by using this kind of analysis. So if you want to have even more concrete numbers, please feel free to join us. The talk is free, same as this one. All right, that concludes the slides. I'll be happy to take any questions if there are some left, and if not, I'm gonna hand over to Sven.
Okay, we have one question coming up that we're seeing a lot lately. Excellent tool. Curious, does TeamScale include any AI components? Doesn't seem to need one. Do you have an answer for that?
It has some, and we even have some talks about this. So all of the like the test gap analysis itself, it doesn't need AI at all. It even doesn't help there. But we have other analyses in TeamScale that consider changes in your code and yeah, try and tell you and give you a reduced test suite that only focus on those changes, or even give you a reduced test suite that covers most of your system, whether you have changes or which changes exactly you have. And for those analyses, we do have some AI-based technologies in the works. They're not released yet, but we are working on this, and we have a nice talk about this by a bunch of colleagues of mine. They should be published on YouTube already.
So we can send around the recordings for these talks as well. Something I also picked up lately is that we have some work focusing on summarizing test gaps. So which is where at least some of the approaches are AI biased, trying to, like, if you have lots of test gaps, to help you get an idea of what's actually the functionality, the concept that's not being tested, to help you add the tests that you're missing at the point, or find the right tests to execute. So that's another direction where AI might come in handy. And I know that we have some functionality when we leave the testing scope and look more at code quality and these kind of topics, which we also cover with TeamScale in general. Then there's also AI support in some areas, but most of this is like in an experimental state, because we are also seeing a lot of false positive suggestions and falsy improvements, hallucinations, whatever you want to call them, happening through AI input. So we're really cautious about this, offering any features like that actually might cause more harm than they do good. So we're playing around with this a lot. We have talks about that where we present what our current state of things is and what we're doing and what we're not currently doing. So and we're always updating this because, as you all know, this field is really advancing at incredible speed. So lots of things to look at here. Now I talked a lot, and I actually there's questions coming in the chat. So how does test gap analysis mix with other solutions available? Apparently Elmar presented at Automation Star, for example, approaches for test selection for long-run tests, to reduce the execution time of tests. How does that integrate with test gap analysis?
Yeah, that's actually the analysis that we're working on AI siblings at the moment. But if you want to use this right now, then this basically uses similar data, not exactly the same, but we need a different kind of coverage for this. So what we've seen earlier, we have seen actually let's go back a little bit. There we go. So what we see is like one package of coverage that summarizes all different tests that are being run. Imagine you have a test suite with, I don't know, 100 tests, and you run the whole test suite, and this is the result that you get, like the aggregated view of the whole test suite. And for the test suggestion parts, you would need test-wise coverage, which means that you basically gather the same data, but for every single test isolated. So you run one test and you need to make sure that nothing else is running during this time. And then after the test is finished, you start a new collection of coverage. And then you know for every single test what kind of coverage you have. And then you can also use the test suggestion part. So it integrates in the same tool, but we need slightly different types of coverage. And of course, you can use it side by side, test gap analysis and test suggestions.
Okay, makes sense. Hope that answers the questions. If not, please feel free to chime in also via your microphones. I think we opened this up for Q&A. So whatever questions you have, if you don't want to type them out, please just use the mic. Okay, so currently looks to me like there's no more questions left at this point. So let me take over the share again here to have some finishing words. Yeah, so first of all, thanks everybody for showing up here. We'll be staying here for some more minutes, so we have some minutes left. If you have questions still, then please bring them up, and we'll be happy to answer them. For the rest of you, thank you very much for showing up. Thanks also to you, Stefan and Johannes, for sharing your insights and your knowledge here at this point. Yes, we will share the slides and the recording with you after the talk. Give us some time for processing. It's already late evening for us here in Germany, so we'll do the processing tomorrow in the morning, and you'll probably receive the recording and the slides later this week, so you can look into this again. Since it seems people are already saying their thank yous and about to leave, we would appreciate some feedback on our format here, also for our speakers and for the organization. So we're going to start the poll here now. Please feel free to leave us some there, and also some free text feedback if you want in the survey that's going to open when you leave the Zoom session. So while the feedback is pouring in here, yeah, all that's left for me to say is actually, again, thank you very much for joining here, for asking your questions. As I said, we're going to stay in the call if there's more questions coming up. There's also more workshops coming up, actually not this year anymore. This was the last online workshop we're having for 2025, but 2026, yeah, is around the corner. And we're going to have more workshops here, starting with the intelligence talk with Vestas about how they actually sold to the management that test gap analysis is worth. Stefan has been referring to that a few slides back, so we would welcome you there maybe again in the next year. And for today, I say bye. Thanks for joining in. Have a nice evening or day wherever you're sitting, and hope to see you around.